Float or sink? STEM activity. Float or sink? How do we know if an object will float or sink? Let's try these objects in a container of water and see what happens. A stick.
What do you think? Will it float or sink?
It will float.
A bouncy ball.
I think this will too float.
A cork.
I think it will float because cork is made of wood and wood is less dense than water.
Good. A sponge.
Same. It is too dense, more less dense than water, so it will float.
A stone.
Stone will sink because it is more heavier or more denser than water.
A marble.
It will sink.
Okay. An apple.
This is a confusing one. I think it will float.
Good. Let's see. Make a prediction before you try each object. So we have done our prediction and it might help to hold and feel each object. Then see if you are right. Does it float or sink? So we'll find out. Why do some objects sink?
Because some objects may be more denser than water.
Meaning more heavier? Okay, we'll find out. Let's see. Which items sank and which floated from the experiment we did? Now we'll learn about density.
Objects like marbles, coins, and stones are more dense than water. Their tiny molecules are really close together. When you put them in water, they sink to the bottom.
So heavy objects are more dense than water. Their tiny molecules are very close together. Hence, when they are put in water, they sink to the bottom of the water. Okay. But objects.
Like corks, wood, and sponges are less dense than water. Their tiny molecules are further apart, so they float on water. Objects that are hollow with air inside also float. This is because air is less dense than water. What about shape?
Let's find out. What about shape? The shape of an object matters too. When more of the surface of an object is touching the water, the object floats better. Let's try that next.
Yeah, sure.
Does the shape matter? What do you think will happen if you drop a ball of plasticine into water?
It will probably sink because the material, the shape is more denser than water.
Uh, let's find out. You're correct that it will sink, but let's find the exact reason why. So yes, it sinks because the material is more dense than water. Plasticine is more dense than water. What is lighter than water?
Air.
Correct. So this sank in water. Now let's change the shape of the ball into a boat shape. Can you make it float?
Yeah, because as I told, air is less denser than water, and the boat has a more surface area which is covered with air, and since uh, the more surface area will get more air, I think it will probably float.
The shape of the boat, because of the shape of the boat, it will float as there will be as the boat is hollow and it's filled with air. Okay. We'll learn about buoyancy. When more of the shape is touching the water, it is more likely to float. The object pushes against the water, but the water pushes back. If lots of object is touching the water will push back enough to make the object float. This means the object is buoyant even if the material is dense.
But doesn't that mean resistance?
Here it's all about buoyancy. Resistance is different. So buoyancy means that even if the material is dense, the object will float. The ability of the object to float is the buoyancy of that object. Can you make the boat sink by adding stones or marbles to it? How many does it need to make it sink?
Yeah, we can make the boat sink by adding stones and marbles, and the number of stones or marbles will depend on the surface area.
Of the boat. So it will depend on the size and shape of the boat. Correct. Very good. Let's look at surface tension. Have you heard about the word surface tension?
No.
Let's find out. Now let's investigate what happens when you put a metal pin or paper clip into water. What do you think? It will float or sink?
In case of tissues, it will float. No.
No, here we are talking about metal pin or paper clip. Whether it will float or sink.
Oh, metal clip. I thought you were talking about tissue because metal clip is a type of tissue. Okay. So paper clip or metal pin will, I think, sink.
It will sink. It should sink. It's heavier. It's denser. Okay. Metal is more dense than water, so perhaps it will sink. Let's find out. Now, what you need is a large container to hold water, some water, tissue paper. Now we'll bring in some tissue paper as well over here. Metal pins or metal paper clips. Washing up liquid or soap. Cotton bud. Optional, a magnet. What to do? Fill the bowl full of water and let the water settle.
Gently place a sheet of tissue paper on the water surface, then put the metal pin or paper clip on top.
Now carefully remove the tissue paper. The pin or paper clip should remain floating on the surface. You could use a magnet to pull it across to the surface to show how it moves around on the top of the water.
Now dip one end of the cotton bud in the washing up liquid.
Put the end without the washing up liquid on the surface of the water first. Nothing should happen.
Now with the other end touch the water surface. The pin or the paper clip should now drop suddenly to the bottom.
Now when you touch the uh, other end of the cotton bud which was dipped in the washing up liquid to the surface of the water, what will happen? The pin or the paper clip will drop suddenly to the bottom of the water.
Wow, isn't it amazing magic?
It is. Now we'll find out why was the paper clip floating and now why does it sink immediately when you add the washing up liquid? Just a touch of washing up liquid, right? So here's what's happening. Surface tension. The surface tension of the water is holding its molecules together strongly. The pin floats on the top of the surface. Soap, detergent and washing up liquid break up the bonds between the molecules and makes the surface tension weaker. The surface tension breaks and the pin fall through.
Oh, nice information shared.
How strong is surface tension? Investigate how many pins can float on the water's surface at once.
Oh,
Some real life examples.
I think it's like lotus floating on the water.
That's a natural phenomena. But here the pond skaters and other pond creatures use surface tension to stay on top of the water. The water creatures. Can you see them?
Whoa, isn't that amazing?
Yeah, those are real life example of surface tension. Boats can float on water because they are less dense than water. The hull of a boat is hollow and the shape helps it to stay buoyant as well. Now I'll ask you some questions. Float or sink? What have you learned about floating and sinking? Let's find out and you will answer them. So it's a true or false question. If a material is more dense than water, it will usually sink.
Of course, it's true.
Let's find out the answer. It is true. Now the second question. You can't make an object float by changing its shape.
It's false because the surface area of the shape matters.
I'll show you. False. Changing the shape may make it more buoyant, so it will float. So it's about buoyancy. Okay, your answer is correct, but you have to use the word buoyant.
Okay.
Washing up liquid or soap helps object floats.
No, as we learned, if you washing up liquid will go, then the surface tension will break.
Yes, and it will make the water molecules weaker.
Yeah.
So false. Washing up liquid or soap weakens the surface tension. So objects floating on the surface will sink. So some things float, some things sink. All because of
Density. The more mass and less air an object
on
has,
an object.
the more dense it is. Less density, float. More density, sink.